Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development. If you work on any code bases larger than Hello World, you're well aware that most of them have nasty surprises in them. If you've tried in vain to fix these things manually, static code analysis tools may be an excellent way to do this. In this episode, we've brought Yuri Minaev from PVS-Studio on the podcast. Yuri is a C++ developer with PVS-Studio, which is a static code analysis tool for detecting bugs and security problems written in C, C++, C#, and Java. But before we get started, Will, what have you been fighting this week?
Well, my book launched yesterday.
Awesome.
Yeah, so the remote development book is live and it's available on Amazon now. That has literally eclipsed everything in my life for the last week or two. Mm-hmm. And I'm actually kind of taking the day off and trying to catch up on things that I had to put aside to get that out the door. So yeah, really excited about it. Glad that it's finally out. How about you, Yuri?
What I've been fighting this week? Well, we are working from home currently, all of us, because the country is under a lockdown. Mm-hmm. People don't really care for the most part, so you can see people on the streets and in shops and whatnot. But most organizations are closed, and we are lucky to be still working because we are an IT company and we don't deal with, real people outside of digital world. So it works, but it's boring as hell, really, to be honest.
Oh, yeah. Well, speaking of work, I'm being pulled in like 3 or 4 different directions right now. I mean, it's not bad, but I have to be really strict about my time because I'll be working on one project and then get Slack messages or emails about another. And some of the stuff I'm doing is pretty cool. I'm actually using what I consider some more complex concepts just because I haven't used them very much before. I'm just making sure I document everything. In school, I took my final exam this past Saturday. That was frustrating. I get that things are different, like Yuri was saying, because of the quarantines and the lockdowns, but these requirements are a bit difficult. I mean, just ridiculous even. For the midterm, I could open it up in Word, type out my responses, and submit it. For the final, we had to print it out, handwrite the entire thing. So I had to handwrite C++.
Like, yeah. The code?
Code, yes. And then scan it and upload it. The thing is, the requirements weren't given before the exam. They were on the exam itself. So I didn't know that until I downloaded it. We were given 3 hours to do all of it from the point you downloaded it. So if anything went wrong in that process, it was an automatic fail. Needless to say, I was a bit stressed Saturday evening when I was doing this. Yeah. Still working on my final project that's due this Friday night, and I'll tell everyone more about it after I finish it. It's also in C++. Would it be cheating if I asked Yuri to help me with it? I'm just kidding.
I don't think it would be cheating. Just make sure nobody knows about it.
Right. Too late.
Yeah, so a few thousand people.
Yeah. No. I've got it mostly taken care of. It's just a lot of work. In better news, Amanda and I took the dogs hiking since some of the state parks have opened back up. That was nice. Did find a new form of exercise, dog wrestling, as her dog cut his paw the other day, and I had to hold him down while she bandaged it. Poor boy. He was terrified. Like he wasn't like angry or anything. He was just scared, and I had to hold him down long enough for her to put the bandage on. So,
if I can add my 2 cents here, I once tried to apply eye drops to my cat. Ooh. And I barely survived it. So,
yeah, I have this big scratch from it.
I had to hold down a small horse with two other people's help. So I don't want to hear it.
All right. So what do you have for us for book club?
This is chapter 10 of my book, Remote Work, The Complete Guide, which came out yesterday. And that's the ultimate list of remote work resources. This chapter of the book lists out a ton of stuff for remote software developers, especially, although it gets into other remote workers as well. This includes stuff for automation, books, blogs, podcasts, career resources, and other things that will help you with your remote work journey. The thing about all this is you can do it the hard way, and a lot of us have had to do things the hard way here lately. That's not entirely necessary. You can learn a lot from other people, and you can get tools that will help you. And so this kind of lists a lot of those out. So who's talking to us this week, Beach?
So just a reminder, we have put comments and water bottles on hold for a short time. A couple of reasons. We're kind of towards the end of our stock of water bottles, and because of everything shutting down, we're not going to be getting any new ones for a while. Also, we haven't been receiving a lot of unique comments. We got a really nice email the other day, and so we're collecting some again. But most of the ones we received are from people who've already received water bottles. Now, guys, if you'd like your very own Complete Developer water bottle when we start that back up, leave us a review on iTunes or comment on the website or any of our social media. We post all of our episodes to Twitter, LinkedIn, and Facebook. We're also on Instagram and Tumblr. Or you could join the conversation anytime via Slack by going to slack.completedevelopernetwork.com. Your advertisement could be here. If you like the show and would like to advertise on here, send us an email to adverts@completedeveloperpodcast.com. We have short-term, long-term, and other sponsorship opportunities. Reach out to us and let us help you reach the people you are serving.
Static code analysis is a way of debugging that automatically examines source code before it compiles or is run. It does this by comparing the code to a set of rules or standards. It's a way of automating code reviews and can be used in conjuncture with peer reviews.
Yuri Minaev, I'm getting that right, am I not?
About right. It's okay.
About right. All right. I am trying. I asked him beforehand. But Yuri is working in the PVS-Studio company as one of the developers of the C++ static analyzer. His primary responsibility is to keep low-level stuff in order and add new features to the core module. It's been almost 2 years since he joined the team after about 12 years of IT experience. Apart from that, he periodically gives talks at various conferences, mainly on topics related to static code analysis and C++. Quick question, Yuri, where do you give those? Well, right now you're not doing them anywhere because all of my conferences have been canceled too. But like, where do you normally give those talks?
Well, they are in Russian normally. I was going to go to C++ on C to UK for a talk, but then this thing happened and everything got cancelled. Yeah. So up to now, I have a couple of, several talks in Russian, and a couple of them were, I don't know if people here know the conference called Core Hard in Minsk. Okay, it's.
I think I've heard of it.
Yeah, there are some English-speaking people there. They visited. Yeah. So I don't know if the audience will be interested even a little bit in those, but yeah.
Do you have any links for those?
Yes, I've got a link for one of my talks in English, which was one of the talks in Russian recorded in our office, just in case, maybe. Yeah, and those links are on our website. I sent you guys a link to my page, so if you want to publish it, go ahead.
Sure.
PVS-Studio is cross-platform, working on Windows, Linux, and macOS 64-bit environments. It can analyze code designed for 32-bit and 64-bit systems, as well as embedded ARM platforms. It generates reports that help developers to find and fix bugs before they become a problem.
So, Yuri, one thing we ask all of our guests before we get into the interview is, what got you interested in programming?
Oh dear. At school, I was attending a computer class. We had some options, and I decided why not. Like the topic of computers was interesting, and considering that I was growing up in 90s, there wasn't much of that stuff around, at least here. So I thought, okay, cool, I should go there. And there we did some quick basic and Turbo Pascal 7.0. That thing was evil, I tell you. Yeah, but it kind of got me interested. I thought, that's cool. And I decided, I heard about C and C++. At that time, I decided to learn those languages. And I didn't have a computer myself, so I ordered some books, and I tried to learn them by books.
So you understand writing out programs by hand.
Oh, I did it a lot. In the university, we had an informatics exam. I don't know why it was a part of informatics. It was more like applied programming or something. So we had to write literally a small program in Pascal on the exam by hand on paper. So yeah, I understand your pain in this case.
Yeah.
Oh man. So so I guess you're probably very, very well suited for the kind of work you have to do, because you're used to having to be very deliberate, for sure. So I guess for the audience, like, how would you describe what static code analysis tools do?
Well, I found at some point a good way, I think, to describe it. It's, imagine code review, but a computer program does it for you. With limitations, of course, it won't be able to substitute a human. So don't you slack out on your code reviews, guys. If you were going to, yes, but it will take care of some stuff people tend to overlook. So it will take care of your typos. It will take care of your stupid checks of pointers and whatever. It will remove some load from you in terms of code review. You will mostly have to care about what algorithm is used here, what containers. You will be able to focus on the structure and the logic, and let the robots do the low-level things.
So what kind of problems can static code analysis tools capture? I mean, like some specific examples.
Some specific examples. Copy-paste. That's our favorite. Because it's the most often, I think it's the most often problem we find in code. Like, imagine you have a condition in some if or something, and it has this or that or that or that or that. Some people do it, believe me. And at some point, you will probably want to copy paste similar blocks of code. And many people, many times, in most cases, I would say, do something wrong with copy pasting at some point in their code. So, for example, you will end up comparing the same variable to different values where you meant to use a different variable, things of that sort. Or you initialize something you didn't want to initialize. It's difficult to find, if you just look at your code, it's difficult to find this kind of problems usually.
Yeah, I was going to kind of follow up on that and ask, like, obviously copy paste would be be one example of this. Like, what are some of the things that it's better? Like, I guess, what are some of the things it's better to have a tool use, like a tool to find, versus what are some things it's better that a human could find?
Okay, so a human will be better at understanding how the code works and maybe how to rewrite it more optimally, maybe do something else instead of what's written, maybe a different kind of loop, maybe remove recursion or something like that. A tool, on the other hand, will check, well, again, copy paste. It will be able to analyze conditions. For example, sometimes people write conditions where some part of it is always true or false, depending on what's written before. Does it make sense to you?
Yeah.
Yeah, you're predicting the branches based off of the previous expression tree, kind
of. Yes, and we can, for example, find cases where you forgot to check if this pointer can be null, and you use it. Sometimes it's surprising. I even find it in our own code base sometimes.
Yeah.
We are not perfect. Yeah. So it's like a function takes pointer as a parameter. And at some point, this pointer gets dereferenced. And it works because zero address never comes there. But at some point, it shoots. Usually when you modify something in the calling code. Because, well, I can go on a small rant about pointers, really.
Yeah, let's do that.
For me, when a function takes a pointer as a parameter, this code kind of smells, usually. Because what is it supposed to do in this situation? Is it supposed to check this pointer for null and leave, like get out if it was null and unusable? What's it supposed to do if it gets a null pointer? I think the calling code should take care of that. And I usually try to change pointers to references if I can when they get to functions.
Yeah, because you're passing it across a boundary, so essentially you don't have the ability to trust all the callers at that point because you don't have control at the level you need, and you can't make assertions about that pointer as easily.
Yeah. And you have to do all those checks, like, okay, I have a pointer. Can it be null? I don't know, maybe. Okay, let's check it for null pointer. If it's null pointer, return. Maybe assert. I see a lot of that in every day, like in many functions in our code, because we have a lot of legacy.
Yeah, I think everybody does. Like it, that's the thing is like if you're at the point where you're successful, probably the definition of that is having legacy code, right? Because you've been around long enough to have it.
Yeah.
It's like it's like, well, you've got dark family secrets because your family's been around a long time. It's just as part of it. Oh man, I've worked on some code bases where we had developers that I'm trying to think of the nice way to put this. You can write Delphi in any language.
Oh yeah, I know that. It's like okay, define open brace begin, define closing brace end, and you go from there.
Yeah, and copy pasting, really, really massive chunks of code over and over again. And so, like every time you go into an if else, there's 5 or 6 levels of that down. It's all in one function, and you can't reason about the pieces. And it turns out that there's only like 1 or 2 little differences between all the different branches, and it like you could just set a variable based on some little condition and get rid of 1,000 lines of code. And I had a thought at one point. I was like, man, if I could somehow get this expression tree, I think I could compare the branches. And I never did it because I managed to get away from that code base. But I was thinking, man, there's got to be there's got to be a better way. So I'm glad to know that your tool can actually do that, because that would help a lot of people out that I know. So, given that, I guess it's probably a good time to talk about why it's important to run code analysis tools before you commit code to source control.
Oh, well, that one is easy, actually. Because, well, let's say you're writing some code. You check it by your eyes. Okay, it's fine. Tests run. Everything looks good. And then you commit it, and then it gets into production or release or whatever. And in like half a year, you get a bug report. Oh, it crashed here. Okay. So the cost of fixing that will be kind of high because it was released. You have to do something. Now imagine that you have some code checks on your CI server. So you commit your code and it gets checked after a night build or however often you make them. When will you know about this problem? Next day, right? So again, you wasted some time, you will waste more time fixing it. If you check it right before committing, you can see everything right away. And what's more important here, this code is fresh in your head still. So you will be able to find what's wrong easier and faster. And it will be cheap.
Yeah, I agree with that. Yeah, because we have that same, we have Linning and we have FX cop rules and stuff like that are running. And our builds, I don't know, it's probably about 45 minutes from a, commit and PR completion before, we find out everything we did wrong. And yeah, tightening that loop seems like it would be hugely valuable. I think the other thing too is like, if your coworkers, pull that code in and then they branch off of it and they've done some other stuff, it makes it that much harder to fix some of those problems because there may be more stuff depending on it and multiple minds in the mix that you now have to get everybody on the same page again.
With all that, what sort of advantages are gained when you integrate a static code analysis tool with your current development environment?
Development environment, do you mean IDE or
yeah,
the
IDE.
entire complex?
We'll start with IDE and get more complex from there.
Okay. Yeah. So if you integrate it into an IDE, it just becomes easier to check it, and I think more people will be willing to do it.
Yeah.
So usually, I'm a developer. I know developers hate running tests or checking their code or doing reviews or something. It's come on, I'm writing code here. Don't you dare. So yeah. When it's easy to use, I think you have more incentive to use it. So yeah. And for the if we are talking about the entire environment, like CI plus build server, like the entire thing, it just makes it faster and easier to find and fix bugs. So that's it. There's no magic. It's just to speed up.
When you're doing it, so it can be at the IDE level where it's developer controlled, or it could be at the CI level where it's out of developer control. So it's not you're relying on the developers to run this tool. It's being run whether they like it or not.
Yeah. But it's encouraged to do it in your, locally in your IDE. You know why? Because you can configure your CI. So if this your static analyzer finds some problems, it can notify you via email and maybe someone else. Okay, this dude did wrong. So that may be one thing you can do to make your developers try it locally. But yeah, it's kind of nasty thing to do, maybe, but we do it.
Well, I mean, I think that's probably a good way to, like you let the developers make their code better, but as a product owner or a manager, you're still kind of responsible for that end product. So you want to catch it, and you also want to know that, hey, this guy doesn't seem to understand pointer math. Maybe we need to fix that. Hopefully you don't have that one, but that's.
Well, the other thing too is it helps your, like, from that management perspective, it also helps your QA to automate some of their stuff too, so they're not having to like catch stuff that should have been caught before it got to them.
Yeah, and the nastiest kinds of bugs are, those that sit and wait because someone forgot something small and tiny in their code. I know that I constantly bump into those because sometimes people write to us to support and complain about some bug in some really old code. And it appeared because it was an exotic case we didn't think of, or because something else somewhere else changed, something gets processed differently somewhere, and it leaked to the old module somewhere.
Well, and I think it's also really handy if you can, you kind of have a set of heuristics that you reuse over and over again for certain types of cases. Like, we were talking earlier, they pass a pointer in. Well, I know I need to check to see if it's null. I need to,
that makes sense.
Make sure that, it's not just garbage where it's going. There's certain things that are going to have to be there. Or I may want to put a rule that, like, for the most part, I don't want to let them pass pointers. Like you said, pass a reference, and force that and say, okay, they have to actually put a thing in there to say override it in this one case and a comment why. I could see that being really useful. Like, you find stuff in code bases all the time that you wouldn't expect. In fact, I actually found one on Yandex the other day. If you put a non-printing character in a string of Russian text saying, like, I'm going to Kiev, but you put a non-printing character before Kiev, it changes it to Moscow. And I have no idea why. But it did that. I filed a bug report. I'm like, I see. It's real easy to have, these kind of strange errors that it's like, nobody did that intentionally, but they didn't think about sanitizing user input in that one particular weird case. It was stuff copied out of a PDF. So who knows what was in there?
Yeah, it's a big problem because there are some vulnerabilities that depend on unchecked input. Like, you can feed some incorrect data and get where you're not supposed to get in the program. Sometimes it happens.
So stuff like buffer overflows and messing with a stack frame and that kind of stuff.
Mm-hmm.
Yeah, that's some scary old school stuff I remember dealing with.
Yes, some people like embedded is a kind of becoming a big deal now, right? It's everywhere, and they use C for the most part, and they code really low level. So for them, I think this is more important than for like someone who writes for PC, but still it can shoot on any platform.
Yeah, I've definitely seen. I mean, even there's still stuff on Windows where that occurs, because there's plenty of code that has to be performance critical, and you can't do it in a high level language.
What's funny is I'm seeing this more, like, things like this becoming more useful as we get more and more cross-platform with what we're building. Just recently, I built a background service in .NET Core that's cross-platform, so it can run on anything, but it was very different from the web applications running on Windows servers that I've built in the past, where I had to be a lot more, because I'm dealing with file systems, I'm dealing with this stuff, and dealing with them not just in one environment, but where it could be in any environment. And as we get to building things that are more cross-plat like that, static code analysis becomes more and more important, because you've got to follow these rules that you set up so that you don't like you might be testing on a Windows or a Mac and not think about, well, how's this going to affect Linux or something like that.
Yes, tools can warn you about that. For example, if you use types which behave differently on different platforms, like for example, long in C++, it what was it? I think it's 32 bits on a 32 architecture, in Windows 64 in 64 architecture, but in Linux it's always like 64 if I'm not messing things up. I don't remember from the top of my head right now, but there are differences in size on different platforms, and they change differently depending on the bitness of the processor.
Yeah, and sometimes the behavior changes too. I remember running into that with Delphi, like where 32-bit it would initialize a pointer and it would zero it out, as it started, and the 64-bit ones it didn't do that. And so if you did things slightly wrong, you could get a pointer going nowhere or going somewhere you don't know, where it's
somewhere you don't want to go.
Yeah, and I mean, like it's stuff like access violations and those kind of things. Like those are awful to try to troubleshoot, especially in production where you don't have like debug symbols. It's like, yeah, program blew up somewhere.
Yes, it was an address, this and that, and the call stack was a bunch of addresses, right?
Right. Those are lots of fun, especially when it's something critical and it's like a big customer that's screaming about this thing because it's broken his production floor, and it's like, well, yeah, it's in the code. It's worth avoiding. So, like, how do these tools? How do they look at the code? I know there's some stuff that's probably going to be corporate secrets, but like, what's the general approach? Do you look at raw source? Do you look at the compile? Do you look at debug symbols? How do you attack that?
Okay, so we look in terms of C++. We look at the preprocessed file. So we take a compiler, usually clang, and we ask it to create a preprocessed file for us because it's faster and it's more precise in substituting all macros and like includes in your CPP file. So we get this huge file which the compiler outputs, and we approach it as a compiler would. So we do all the usual stuff. We do parsing, building an AST for that code, and then we start. Well, the compiler at this point would, optimize it and go to code generation and optimize it again. We at this point walk the tree and we determine types of each node, like types of variables. We calculate values of variables if it's possible. And we then run diagnostic rules. Like different diagnostic rules want different kinds of nodes as an input. For example, some of them work with function calls. Some of them work with if statements, and so on. So the walker, the part which walks the tree, it takes care of which rule to call in which situation. And the rules themselves, they look at this piece of tree they get, and then if some values are known for variables, they can take them into account. So we have the data flow analysis, which tracks what happens to variables, basically. So it's kind of a sophisticated system, but it's no more sophisticated than a compiler, I think. The front end of the compiler, not the optimizer.
Yeah.
That one is really crazy.
Yeah, you gotta. Well, I mean that part of any compiled system is basically voodoo. It's just, that was the biggest thing I learned in assembler was just like some of the stuff you have to do because of the the architecture. Stuff like XORing the contents of a register with itself instead of putting 0 in there. because it's faster because of
yeah.
and you're like, okay, when this scales up to a full size program, like there's a lot of stuff, and that's not even looking at multiple threads and looking at like some of the caching stuff. It's not messing with L2 cache, any of that. So yeah, I get why you dodged that part. That's that's commendable to not have to do that.
Well, fortunately for us, we don't have to optimize anything, and the less it's optimized, the better for us because we have more information.
Yeah, because I guess you just do like a visitor pattern type thing, and just like you said, walk the tree and then go, okay, it's this type of node. Here's the rules I want to apply against it, and you have basically a set of assertions you can do against that and kick out messages. So I mean that makes sense. That's kind of how I would think it would have to be done. I would imagine that would be still not super duper easy though, because you're gonna have to lex and parse and do all the. I mean, I guess after Clang normalizes it, it's probably not as horrible as just raw code from random C and C++ developers, but it's probably still not super fun in a lot of cases.
And this is why you have a tool for doing this, and you don't do it yourself.
Yeah, yeah, because you can't. I mean, you can't reason about it at the once you start getting ASTs that are 15 calls deep, for instance, or dealing with recursion and pointer arithmetic and everything else all in the same spot. Like it, yeah, you can't get there from here. Like you really need code to do that. So what kind of outputs are most useful when you're doing a static code analysis tool? Like if you're integrating that, like what typically is something that the customers find most valuable when they start out?
Well, there's only one kind of output really. It's the error warning log. So it's a report. Well, some things there are more useful than others, of course, but that's why we sorted them in different categories. So they have priorities. We put the most interesting stuff on top. And the stuff we are sure of. Like if we are really certain, okay, there's an error here, it will have higher priority than if we are unsure.
Okay, so you would catch like going back to the null reference thing, it's like if they have code that sets a pointer to null and then passes it to a function that tries to use it, that's not going to be a compiler error, but that's going to get caught by you, and you're going to be like, dude, this is not correct. There's no way this is right.
Yeah. Or there is a really funny pattern which happens in many open source projects, really, because we check them sometimes. It's when your function gets pointer, and then you use that pointer, you dereference it, and after that you check it for null. That's kind of funny. I don't know where it comes from, but it happens over and over again. So first a dereference, and then somewhere a check for if it was a null pointer.
That is strange.
That's strange. Yeah.
Maybe multiple people getting into the code base and not, they're just looking in a narrow area. That's the only way that could happen, I guess. Or not understanding what null is, which is kind of horrifying.
Or it's a pattern that they have seen other people do, and going back to copy paste, they just reuse that same pattern over and over.
Yeah. Well, if you make the code look like everybody else's code, you don't get blamed when your particular part breaks. It's like it's up to standard, even if the standard's wrong.
Okay, it's everywhere. Why shouldn't I do it?
Yeah.
What was that? I'm trying to think of. There is some architecture, some CPU, maybe it's ARM, where you can write at address 0. So it's legal to write from 0 to up the address.
Okay. Yeah. That's interesting.
I think it's for bare metal coding only, and they have some system handlers there, and you can set your hooks. If I'm not getting things wrong, don't quote me on that. But there was a chip that did that. Sure. That allowed you to write at 0.
Yeah, and if somebody comes in and sees code like that and doesn't realize that's unique because they just happen to start their career working on that system after being a web dev, I can see that being a real problem when they switch over to everything else. So yeah, it's worth catching. And then what are some of the less useful things? Would that be stuff where it's like, hey, this is user input and you don't know that it's got a certain length and you might need to check that? Or
the least useful input, I think it's we have a diagnostic rule for that, and it came from long ago. It's like, dude, you have a field which has a pointer type in your class. Oh my goodness. And you know why? Because on 32 bits and 64 bits, the pointer size is different. So if you put it in your class, the class size will be different. It came from long ago. It's not really useful. It's more annoying, and usually it's suppressed. Maybe many people, I think, just disable those 64-bit diagnostics.
Yeah, I mean, well, and I guess that's the next thing to get into is why is it so important to be able to suppress all the critical warnings? I mean, I think we all know, but probably for the benefit of the audience, why is that so handy?
Because you don't want to have clutter in your output. You want to see relevant stuff, especially if you try to analyze an old project, which you have never analyzed before. You will get a lot of garbage in your output because there's a lot of code the analyzer sees for the first time, and it's really difficult to deal with it. If you try to, and if you manage to fix all of that, I will buy you a crate of whiskey or something.
But really, you're just kind of making them whole at that point because they are probably drank a crate of whiskey while they fixed it.
It's not a challenge. Yeah. If you manage to fix all those thousands of warnings you get on an old big product, yeah. So it's important to disable most of that stuff. And usually what first gets disabled is those low level of certainty warnings, low priority, basically.
So I'm curious, like we've talked kind of about what a high priority, low priority would be. How do you guys determine your level of certainty?
Well, there are two factors in that. First, if we are sure that, okay, that's an error, the level will be typically higher. So that's one thing. And the other thing, we use things like CWE, it's the common weakness enumeration, and we look at the severity of things that can happen. And for higher severity errors, the level will be higher. So stuff like you have a pointer in your class, it will be down there at the bottom. So it's not really important. But stuff like you have you have an overflow here because you tried to memcopy a large buffer to a small memory area, it will be higher. So the severity and whether we are sure or not.
So it sounds like it finds a lot of stuff. What limitations are there when you use automated tools to examine a code base? Like what kind of stuff can you not catch?
Multi-threading. That's a bane of our existence. Because to catch a multi-threading problems, you need to access the runtime. There's a really tiny subset of problems you can catch in static. That's one really huge thing. And the other thing is, how C++ is compiled. The compiler gets all the translation units in parallel, and then the linker comes in and does the rest of the job to assemble your executable. We don't see other modules, so we look at one translation unit at a time, and we complain about one translation unit. And that's for speed, because if we try to implement something like a linker and analyze across compilation units, it will take forever.
Right, because you have a bunch of interactions you got to think about that you wouldn't otherwise.
Yes, so we are kind of blind to things which are not in headers. If it's in a different CPP file, we don't know about it.
I mean, that makes sense. I mean, there's a certain level of complexity that the tool just can't get, but it can get all the other stuff so that the developers can worry about those things. I think that's probably the big win there. So I guess if somebody wanted to get started using a static code analysis tool, how would you suggest that they go about that?
Well, a typical suggestion is you run it once, you look at the report. If you see a lot of trash like false positives, you suppress them all. So we have that mechanism for suppression of basically everything you want to suppress. What it does, it tells the analyzer, okay, look, those warnings, I don't care about them right now. Just don't bother me with them anymore until I tell you to stop doing that. It keeps silent about the warnings you don't want to see. And then you start writing new code in your project, or you do some refactoring or something like that. You fix some bugs. You run the analysis after every build, and you look at the new warnings on new code. Well, we found that is probably the least painful way to introduce it into an old project. If you have a new code base, like it's small and it's expanding, just run it. Just run it after every build and fix problems as they come, because you won't get too many. You won't drown in them.
And they'll be fresh too, so you'll know where the screw up was. It wasn't something from 20 years ago.
Yeah, maybe I would, if I was trying to implement some code analysis, like if I were to decide to use PVS-Studio in my code, for example, in my project, I would certainly disable some sets of rules, like 64 bits, that stuff which complains about pointers and classes and whatnot. I would disable those, and I would filter out everything on the, except two first severity certainty levels of warnings. So I would do that. And one important thing about that is, if you are serious about using static analysis, you have to do it regularly. You need it in your CI. You need it in your nightly builds.
Yeah,
because it's more efficient. If you use it like once a month, it won't be efficient. Your code will be, let's say, polished by hand, and you will spend more effort polishing it than you have to.
Yeah, because I mean, the thing there is getting that feedback loop between the tool and the developers and keeping that going. Because I mean, the other thing that I think a tool like this is probably going to do is, over time, it's going to make your developers better, just because they're tired of seeing that same warning message. I mean, there's stuff that comes up in Visual Studio, just with C# with certain warnings, and I'm like, yeah, I'm gonna, I've broken some habits by that, just by being annoyed by the very minimal tools that are just built in. So yeah, it seems like that you want to get that as early as possible and as often as possible to try to catch things, and then get more and more. You just get like the real serious ones at first, and then you just kind of build up. And as you've cleared the serious ones off, you can start handling some of the less serious ones, once the big issues are handled. So what are some signs that a code base could really benefit from static code analysis? Like, how do you know, if you're just were dropped into a new project, how do you know that things are at a level where you definitely would say, okay, let's go get a static code analysis tool on this, and sell that to management, if that makes sense?
Yeah, it makes sense. And it's this one is really interesting because what science? Right? I would say if you are maintaining your code actively, if you are doing like edits here and there constantly, it can help you because your edits they can also break something, especially if you are doing it on legacy or on old code. So if you have a huge legacy layer, you will probably benefit from it. If you are if your project is fresh, probably you won't see it as an immediate great benefit solving all the world issues. But I think it's worth using still because less bugs will creep into your code. And I would say if you sometimes get weird bugs from your program, like something you have a hard time catching, I would introduce some kind of static analysis tool and probably a sanitizer also in your tests.
That makes sense, because if you're getting weird bugs that are coming out of nowhere and you can't reason about where they're coming from, having a tool that actually goes and finds the places where they might be coming from is valuable all in itself, even if you don't take most of the suggestions. If it just finds the one that you're looking for, and you don't tie up developers trying to do that, that could be a pretty quick win. Now, is there any kind of team aspect to this as well? Like, do a lot of these tools hook into things like source control providers and look and say, okay, who created this issue? Or like, could you like do a graph of like all the changes since a certain point and go, hey, this issue was introduced at this point?
Yeah, we have integration with some source control systems, but they are mostly for pull requests. So we don't really look at the history of everything. But yeah, we can understand who committed the code which had an error.
So you could potentially direct the error message back to the person that wrote it.
Yes, that one's easy because we analyze after each commit. Basically, how it's set up in our code base. It runs nightly on the CI, and it looks at all commits from the previous run. It looks at all commits made during the day. Let's say that, and then it tracks changes. So if it finds a new error in some file, it checks the blame who did that, and it notifies that person and the team lead.
So how would you? I know we kind of got a lot into the C++ aspect of it, but you're going to have developers that are going to say something like, "Well, I run on a managed platform like C Sharp, Java, that theoretically does at least some of your memory management for you." And, they're going to come back with, okay, well, it looks like my platform covers that. How would you respond on that one? Because I think there's a lot of stuff that the people that are on those platforms don't realize about the kind of problems they can still have in their code.
I would say C Sharp, I'm sure. I'm not sure about Java, but they have nullable types, don't they?
Yes.
So those are pointers, and you can mess them up exactly the same way as you can mess up any pointer.
Yeah, we also have pointers too. We don't. I think I've used them twice, and I've been using C Sharp since the beta. And I don't mean core. I mean, like early 2000s. Actually, I have the .NET Framework beta discs somewhere in my desk here.
Wow.
Because I don't clean very often. But Yeah, they were just like out somewhere, and I just stuffed them in the desk. And I see them every 6 or 8 months when I have to go look for something.
How many times have you moved since then?
Look, that's not relevant. Look, if you're a slob before you move, you'll be a slob when you get where you're going. It's not any different. You'll just have more place to mess up, which is kind of the idea. But yeah, there's a lot of those kind of things, and there's also stuff. I think where there are performance issues that people that your tool probably would catch that people don't think about, or that they don't realize that the compiler or the runtime is doing some things under the hood. We've got like a lot of syntactic sugar, for instance, in C# where, things like, event handlers, it's basically a delegate or it's a callback mechanism. And if you're calling that callback and it doesn't have anywhere to go and you're doing that in an unsafe way, like you can get burned by that. And there's a lot of those kind of issues that people don't think about. I was just curious if you had any others that maybe are even worse in the higher level platforms.
I'm not sure about worse because, we have C# and Java, but C is the most developed part right now. C# is not too young. It has some collected base of found issues. Java is really not that old, and it's still actively developing, so it's growing features. So I'm not sure exactly what we can find, but for sure we can find some things. There are fewer ways to shoot yourself in the foot in a managed system, of course, but there are still ways to shoot yourself in the foot.
Oh, I've done that before.
I've done that with handle leaks in Windows.
Handle leaks.
And made it where the start menu wouldn't open. Because this was, good grief, this was probably Windows 2000 or XP time frame. But I leaked enough window handles and had them allocated that it couldn't create any more on the system. And that is rather profound to try to fix because you can't open a menu to close things. And like Task Manager wouldn't come up. It was bad. And I did that with C# code.
Well, technically it wasn't C#. I think it was Windows.
It was
general
Win32.
Windows issue with those handles. Because if you forget to close them, this always happens. And that's kind of funny because, there is one complaint I hear about from people about C++. Oh, you have to manage your memory manually. It always leaks. Come on, dude. You open a file, you forget to close a file, your handle leaks.
Yep.
And I have unique pointers and my memory doesn't leak. So where's your gut now? I'm sorry. It was yeah.
I love it. No, that's good. Hey, you know what? Will and I are both C# developers, so we make fun of Java all the time.
Yeah.
So, it's good to get it. We give it out, we dish it out. It's good to to get it some too from a C++ developer.
Well, the thing is, with those higher level languages, a lot of developers feel like they're safer, and a lot of times it's kind of false because
it's definitely a false sense of security there.
The runtime will deallocate stuff for you, possibly. Because I could see situations where you have, for instance, with the garbage collector, where you have a really large object that gets down into Gen 2 or Gen 3 of the garbage collection and doesn't get deallocated, and you've got poor management of handles and stuff that are hanging off of it, and it just stays there forever.
Yeah.
Not that I've ever done that with very large chunks of memory or anything like that. I would almost make the case that it's probably more important in the higher level platforms to get that stuff right, just because your developers aren't aware, and so many of them don't understand that they really do have to manage memory and think about that stuff.
What's the most evil thing in C#? I think cross references between objects when they like objects point to each other and they don't let the garbage collector to do anything.
That was more common with COM.
Mm-hmm.
But it is possible to do that with the garbage collector. The one that I see a lot of is just where somebody keeps a really big chunk of memory around for way too long, and then it just stays because the garbage collector responds to pressure more than it does anything else. Like it's not going to do a GC collect just because, reasons. It does it, okay, I'm running out of memory in this, part of the heap, so let me get rid of that and, recompact the heap basically. And if you got something in the bottom, it doesn't get touched.
Oh, okay.
You have to think about lifetime. And I mean, there's just a lot of that kind of stuff where it's managed for you, but it doesn't mean it's necessarily managed competently.
Mm-hmm. Yeah. Yes. And to me, garbage collectors are something like, I don't know, dark magic maybe, because I heard a story once at one of the conferences. The guy told me that they had some code in C# and it was working great in their like regular module, in their regular executable. And then they decided to put it inside a Windows server service, which ran with some kind of special privileges, something. And they ended up with a hanging system because the garbage collector went crazy and killed everything, basically.
Yeah, you can do that. Also, you can run C# code in SQL Server. So like in the database server, and it's got special stuff that it does that's different than the regular runtime. And I don't know that those conditions are really all that widely known in the community. I mean, that's that's one thing about static code analysis tools that they do a lot for you is they are a repository of knowledge of ways that people have screwed up in the past.
Yeah.
So it's like I'm instead of, if I can't get a developer that knows all the ins and outs, I can buy a tool that catches stuff like that developer would catch them.
Oh, our favorite error. I don't know, maybe everyone has heard about it by now, but people sometimes want to zero out some sensitive data in memory. And they typically, what they do, they put a bunch of zeros there in that area. And they like to use memset, the memset function in C++. It just takes a value and a memory block, and it puts the value all over this memory block. Guess what compilers love to do?
Not do it.
They look at the memset call and go, this buffer here is not used anymore. Why do you want to zero it? Let's optimize it away.
Yep. I could also see that, you could, if you're monitoring that program at runtime, you could potentially find the places where those things are, where big chunks are being zeroed out and go, hey, there's something critical here. And so like you might want to write garbage to it instead of writing zeros just to kind of make that a little bit harder.
Well, maybe, but I'm not sure if it will help, but because there are no usually fixed addresses where everything is stored. So
right,
it's dynamically allocated in many cases, or it's on stack, but the stack gets like the stack address can be randomized every time you launch your application. So it's I don't think it's a big problem that someone can see a bunch of zeros suddenly popping up somewhere in memory, but that people rely on something basic like a memset to zero out a memory block, and they see it working on debug, of course, because optimizations are disabled. That's why it's more evil. And in release, the compiler goes crazy with optimizations, and suddenly your passwords are left where you put them.
Yeah, I could definitely see the value there. We're getting kind of close to time to wrap up. We did get a link. We're going to have this in the show notes for trying out PVS-Studio, and if you enter there's a promo code. It's hashtag CDP, all caps in the message field, and you get a free trial key for a month instead of 7 days. And we'll also have this information here in the show notes for the episode. Keeping a code base clean and detecting problems before they occur will make your life a lot better as a developer. When you can avoid getting nailed by simple problems, you can think about your software at a higher level, vastly improving your effectiveness as a developer. It's not just about avoiding bugs, although that's important, but about what you can do with the time, money, and attention you save. And that pretty much wraps us up. Beej, what do you have for us this week for Tricks of the Trade?
So, since this is my last time doing Tricks of the Trade, I'll be back on book club next week. And we're talking about bug fixes. I have a little bit of a story to tell you guys. This recently happened to me where I had to watch another developer fix a bug in code that I had written a while back. And kind of while showing him like around the code base, I saw that others had been in there doing things different from the patterns that I had established in the code. It was really frustrated. I wanted to say, nobody's allowed in here. I'll do all the fixes from now on. But I didn't, because then that's all I would be doing is bug fixes from now on, and I don't really want to do that. What I'm getting at here, guys, is it can be hard to let things go, especially when it's a project that you might have been the primary developer on for a while. You don't want to let other people in there to mess around with the things that you set up, the patterns, the paradigms, the way that you designed that code base to work, your architecture, basically. However, in order to move forward, we have to move on from our old code. There are developers who spend years building a large, intricate system, but then they don't allow anyone else to get in there and maintain it. And this means they spend a few decades maintaining it themselves. And if you don't want to spend your career maintaining something you wrote early on, then you have to allow others to make changes in your code. That's pretty much all I've got. Yuri, thank you so much for coming on and talking to us. We really appreciate that. I know you mentioned the link on the website to your stuff. Is there any other way that people can reach out to you if they have questions?
I think the best way would be by email, because I'm one of those guys who's not on the social network. I think I'm a bit of a dinosaur, maybe. So you can put my email in the notes or leave it as a contact. I know you have it, guys. So
yeah, we'll add that to the show notes. People can reach out to you. All right. Well, hey, thank you again.
Yeah, it's been fun.
Oh, thank you guys for letting me in.
All right. Yeah, it was very, very educational. All right, guys, that's it.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.